This is a pre-built version of the application. So let's go ahead and run it. And we'll have 4 peers. So this would be the first one, second, third, and number 4. And each peer will pick up messages coming from all others. And let's go ahead and start mining on each one of the peers. So this peer succeeded in mining this block. And the other 3 verified it. Now hashing is taking a string of any length as input and producing a fixed length output. And here we are using SHA-256, the one used by Bitcoin, and it produces a 256-bit hash. And since we are displaying in base 16, we end up with 64 characters. So this is the hash for the username and the timestamp and the nonce and the formula that uses logical operators that was discovered. And the proof of work is to have this hash be smaller than this max bound. And here we are using genetic algorithm in order to evolve the population of groups of expressions from one generation to the next, using selection, crossover, mutation, and elitism. So we went to generation 230, where we discovered this group of expressions with a fitness of 7. So all 7 expressions have their calculated results equal to the expected results. So this is a table representation of this row. Which has the highest fitness. Since we are sorting by fitness. And this is discovered formula in regular notations, and this is that formula in postfix notations. So we are using those 6 truth tables. So for AND, if both X and Y are true, then the result is true. otherwise the result is false. And for OR, if either or both x and x or y are true, then the result is true, otherwise it is false. For XOR, if x is equal to y, then the result is false, otherwise it is true. And NAND is the inverse of AND, so here we have 3 zeros and a 1, and here we have 3 ones and a 0. And NOR is the inverse of OR, same thing, here we have a 0 and 3 ones, and we end up here with a 1 and 3 zeros. And XNOR is the inverse of XOR, so here we have a 0, 2 ones and a 0, so we end up here with a 1, 2 zeros and a 1. And I picked those symbols to represent the NAND, the NOR, and the XNOR. So here we ran with data coming from code. So we have 8 events and an expected result. And here we have data coming from file, so data 01, and we run that with file driver. And here we have we handle data coming from the database. So the file name is data.db. And the other peers didn't get to do any hashing since they were trying to find a formula, and they did not succeed. The best fitness here is 6, so we have those two are different between the calculated result and the expected result. And same for the other two. This one, so here we have those two are different, and this one, here we have those two are different. So those other peers received the username, the timestamp, the nonce, and the formula, and what they did is to do the hashing and made sure that it is smaller than the max bound. So the proof of work here is a piece of data which is time consuming and costly to produce, and this means it needs a lot of electricity that is spent on computing resources. So we end up spending a lot of energy on trying to solve a basically useless problem. Essentially, we are checking if a continuously varying number, meaning any one of those hashes is smaller than another number, this max bound. So the idea of this prototype is to experiment with trying to solve problems with part of the energy spent. Specifically here we are doing data mining in order to find a formula that uses logical operators, so we spend part of the energy in finding this formula here. So what I did here is to modify this project, the first cryptocurrency project, and I added data mining using logical operators to the proof of work. This code here, and we're doing a simplistic approach. So we are just using the discovered formula as part of the block that gets hashed. And the source code will be available for download. Also a longer version will be available for watching by channel members, all channel members, and it will include step-by-step coding plus test running the coded application.